Hello viewers, I hope your day is going very well. Today we are going to discuss about domain and range, how to find domain and range of a given function. But before we continue, please, we are making a new videos, try and like, share, comment and hit the notification box. Don't forget to subscribe. So we are going to find a range and a domain for the following functions. But before I continue or before we go to the examples given, let me explain what we mean by domain. The domain is the condition that makes a given function to have real numbers. For example, if you have a function like f of x is, let's say, 2x, the values of x that makes this function defined is what we call the domain. The values of x that makes the function to be defined. And if you have a function like f of x equal to the square root of x, the values of x, the numbers you put here, that the functions will have real numbers, is what we call the domain. So, for example, if you put values of x as 0, 1, 2, 3, 4, the function will have real values. But if you put the values of x to be, let's say, -1, -2, -3, it means f of x will not have a real value. It will have an imaginary value. Now, to summarize what we have done, from here, if we put the values of x as 1, 2, 3, 4, 5 continuously, what we are taking is, we are taking numbers that are greater than or equal to 0. That means for this function to have real numbers, the values of x here must be greater than 0 or must be equal to 0. But if we take numbers less than 0, the value of x here or the function will be imaginary. So that is the first thing. The examples we have there, we have functions that are dividing some functions with square roots. Now the first function we have there is, the function is y equal to root of 2x plus 10 divided by 16 minus x squared. This function has a denominator. So for this function to have real numbers, this denominator must not be 0. By saying it must not be 0 means it must be greater than 0. If we put 0 here, the whole function will become undefined. So the value of x, the value for this function here, y, to have real numbers, the denominator here must be greater than 0. That's the condition. So we are going to take our 16 minus x squared to be greater than 0. To be greater than 0, so we simplify. 16 same thing as 4 times 4, which is 4 raised to the power of 2. So what we are saying here is same thing as 4 squared minus x squared is greater than 0. Remember, what I expressed as 4 squared is this 16. The next thing is 4 squared minus x squared is same thing as, is difference of 2 squares. If you have 4 squared minus x squared, you have to simplify them or factorize them into 2 brackets, where the first bracket will contain 4 minus x, and the second bracket will contain 4 plus x greater than 0. At this juncture, to properly know the value of the domain, we'll go back to our sign chart. If you have a problem with sign chart, I will make videos for that. So if we are to do our sign chart, in our sign chart we have about 3 different values. What we have factorized, the first factor here is 4 minus x. The second factor here is 4 plus x. And we have their products. Okay, so if 4 minus x is greater than 0, that means the value of x here will be greater than 4. For this side, the value of x here will be greater than -4. That is not really too important, but we start from the less values, the smallest value. How to represent the values here for the sign chart is, normally x will be less than the smaller number. In the second part, the smallest number will be less than x, and then will be less than the biggest number. So the first part is our x will be less than minus 4 is smaller than 4 minus 4. The second part is the smallest number minus 4 will be less than x and will be less than the biggest number 4. And the last part is our x will be greater than the biggest number 4. So we are going to take range of numbers and test for each of the inequality I have represented here. For x less than minus 4, we are taking numbers that are smaller than minus 4. So numbers smaller than minus 4 are numbers like minus 5, minus 6, continuously. So let's take minus 5 because it's smaller than minus 4. Minus 5, if you substitute minus 5 for the position of x here, it will be 4 minus 5, which is the same thing as 4 plus 5. So it's positive 9. If you use that the same minus 5 we are taking and replace it here, it will be 4 minus 5 is negative. Plus times minus is minus. Let's go to the second factor. This other side. Minus 4 is less than x and less than 4. So there are two things here. We are combining two inequalities. From the first part here, if minus 4 is less than x, that means x is greater than minus 4. So we are taking range of numbers that are greater than minus 4 but less than 4. So numbers greater than minus 4 are numbers like minus 3, 2, minus 1, 0, 1 to 3. Let's say 1, 2, 3. These are the range of numbers. So numbers is greater than 4 but less than 3. Greater than minus 4 but less than 4. Let's take numbers like 3 or like minus 3. If you take your minus 3 is bigger than minus 4 and it's less than 4 itself. If you put your minus 3 here, it will be 4 minus 3 as positive. You can test for other numbers. For example, if you are taking positive numbers here, 2 or 3, 4 minus 3 is still positive. Okay, so let's test for this one, 4 plus x. We are taking minus 3. So 4 minus 3 is still positive. Their product, plus times plus, is plus. Then lastly, we are taking range of numbers that are greater than 4. Numbers greater than 4 are like 5, 6, 7, continuously. So we're taking 5. For example, we take 5 and test. 4 minus 5 will be negative 1. 4 plus 5 is positive. Their product is negative. Now, how to get the domain now after doing this? From our question, from where we sit here, please take note of this very well. The sign here is positive. 16 minus x squared greater than 0. So if the symbol here is greater than, then you take the ones with positive. Or if the symbol here is less than, you take the ones with negative. So that means our domain will be range of numbers that are greater than minus 4 but less than 4. Numbers greater than minus 4 but less than 4. So numbers greater than minus 4 are minus 3. Let's use it in a equal bracket. Minus 3, minus 2, minus 1, 1. Capital minus 1, we have 0, 1, 2, 3. This is the domain. Therefore, if you don't want to do this, actually, you can do something like this. Because of the bulkiness of the work, you can reduce them to minus 3, comma, and then 3. We'll take this as domain. This symbol here is telling you that there are other values between minus 3 and 3. The next value is to find the range. For us to get the range is simply substitute the values that are here in the given function, the original function, this original function. So at times it's not needed to show all the workings, but if you want to show, it's good. So let's substitute minus 3 into this given function. If you substitute minus 3 to this given function, you have something like the square root of 2 times minus 3 is minus 6 plus 10 divided by 16 minus 3 squared is 9. That means we are going to have the square root of minus 6 plus 10 is 4. 16 minus 9 is 7. So you have 2 divided by 7. So our first range is 2 divided by 7. To get the second value here for 3, we also use 3 and substitute to the given function. The original function gives us. Use 3, we're going to have square root of 2 times 3 is 6 plus 10 divided by 16 minus 3 squared is still 9. This will be equal to 6 plus 6. 6 plus 10 is 16. The square root of 16 is 4 over 7. So we have 4 over 7. There are other values in between. 4 over 7. So this is how to calculate our domain. So that this is our domain. This value stands for our domain. This stands for our range. So that's how to solve the first question. Alright, we are done with that. We'll proceed to the second question. The second question is y. The function is y equal to the root of 24 plus 10x minus x squared. We have to find the domain and the range. If you have any question concerning this, you can inbox me. Alright, so to calculate for the first value, for the second question, it's still the same method. The same method. Y equal to the square root of 24 plus 10x minus x squared. Okay, so for this function to have real values, everything inside the root will be either 0 or will be greater than 0. If everything here has a negative number, the function will have imaginary values. So we don't want imaginary values. So to get the domain, to get the value for x here, we let everything here to be greater than or to be equal to 0. So that means our 24 plus 10x minus x squared will either be equal to or greater than 0. So this implies here our x squared, the coefficient of x squared is minus 1. What is standing for x squared is minus 1. So we need to make it unity, positive unity. Positive unity means what is standing for x squared should be positive. How do we do that? We divide everything here by minus 1. So that it will become x squared minus 10x minus 24 is greater than or equal to 0. Alright, so I'm going to find two terms in the unknown. Two terms in the unknown that will multiply to give us minus 24 and we add to give us minus 10. Two numbers or two terms in the unknown. That in the unknown means with x. And when we multiply them, we are going to have minus 24. And when we add them or find the difference between them, we have minus 10. So 6 times 4 is 24. 12 times 2 is 24. There are so many numbers that you can multiply to give you 24. But we must test for the sign to be equal, to be the same. This sign here, when you are summing them, must be negative, and here must be negative. So we are going to do 12 times 2. If you do minus 12 times 2, you have minus 24. Minus 12 plus 2 is minus 10. So the two factors are minus 12 and plus 10. So let's solve for them. It's going to be x squared minus 12x plus 2x minus 24 greater than or equal to 0. So we factor out what is common here and what is common here. That means we're going to have x into x minus 12. That's for this and this. Here will be 2 into the two brackets must be 12, x minus 12 greater than or equal to 0. So we are going to have x plus 2. These two terms are outside the bracket. X minus 12 greater than or equal to 0. I think from here, our values for x will be either minus 2 or positive 12, or you can just say 12. The sign here actually doesn't matter for now. The sign here is to help us to get the range and the domain after solving using your sign chart. So that's why I just use equal to. Okay, let's go back to our sign chart. To get to our sign chart, we will have the first factor here is x plus 2. Second is x minus 12. Then we have their product. The rule is x is less than the smallest number. The smallest number is minus 2. X less than minus 2. After that, we are going to have the smallest number minus 2 is less than 12. So it's less than x is less than 12. And then lastly, x is greater than 12. So let's test. X is less than 12, less than 2. The numbers less than 2 are numbers like minus 3, minus 4. So let's take minus 3. If you put minus 3 here, minus 3 plus 2 is negative. Minus 3 minus 12 is negative. Their product is positive. For here, minus 2 is less than x, and it's less than 12. So if minus 2 is less than x, that means x is greater than minus 2. So numbers greater than minus 2 are numbers like minus 1, 0, 1, 2, 3 continuously. But it's less than 12. So we are ending in 11. So if we take minus 1 for example and test. Minus 1 plus 2 is positive. Minus 1 minus 12 is negative. Plus and minus is minus. Lastly, we have x is greater than 12. Numbers greater than 12 are numbers like 13, 14 continuously. So here will be positive, here will be positive, and here will be positive. Now, the symbol here is, the symbol we are using here is greater than or equal to. So greater than or equal to is telling us that we are taking two positives for greater than two positives. So that means our domain will be ranges that are greater than or equal to minus 2 because it's positive, and then greater than or equal to 12. So these are the two values for our domain. To get our range, for our range, we are going to substitute minus 2 to the original function, to this original function to get the range. So let's try it somewhere. If you put minus 2 here, our y will be equal to the square root of 24 minus 2 times 10 is minus 20, minus 2 square is 4. 24 minus 20 is 4. 4 minus 4 is 0. That means our range here is 0. If we take values for 12 itself, we are going to have 24. 12 times 10 is 120. 12 square is 144. And then root. 24 plus 120 is 144. Minus this is 0. So this is our domain. This is our range. Very good. We'll go to the third one. We are following up very well. If you have any question, inbox me. Please don't forget to share, like, and comment. It's a free lesson. The third one, we are asked to find the range and the domain of y equal to 1 divided by 6 root x. Okay, for this function to have real values, everything in the denominator must be greater than 0. If you put 0, the function will be undefined. And you use numbers less than 0, because of this root, it will still be imaginary. So to solve this, we are going to let everything in the denominator be greater than 0. So how do we get the values for x? Divide here by 6, here by 6. So it's going to be left with root x is greater than 0. If you square both sides, if you square here and square here, our x is greater than 0. Now, to get the domain, this is simple. For the domain, Numbers greater than 0 are numbers like 1, 2, 3, 4, 5, 6 continuously. So after taking 1, instead of writing 2, 3, 4, 5, 6 continuously, you use infinity to represent the other values. And then for the range, you replace these values into the original function. If we put our 1 here, it will be 1 divided by 6 root 1. Square root of 1 is 1 times 6 is 6. So our range is 1 over 6. And if you use infinity here, you're still going to have infinity as our value. So this is our domain, this is our range. Let's try the last one, D. I'll leave E for you to solve. It's an assignment. You can leave E1 for you to solve. It's an assignment. Okay, let's solve E. I'll leave this for you as an assignment. E says y is equal to the square root of 4x minus x squared. Same thing. Everything in this root will either be 0 or must be greater than 0 if you must have real values for these functions. That means our 4x minus x squared must be greater than or must be equal to 0. To factor out what is common, here x is common, we will have x into 4 minus x squared is greater than or equal to 0. Alright, so 4 is same thing as 2 raised to the power of 2. Take note. So if you have 2 raised to the power of 2 minus x squared is the difference of 2 squares. So what you're having there in general is something like x into x, 2 minus x, 2 plus x greater than or equal to 0. So our values for x here will range from 0 to, okay, let's start from this, minus 2. From here it is 0, from here it is 2, from here it is minus 2. So the smallest number is minus 2, followed by 0, and followed by 2. So look at how I'm going to arrange them on the sign chart. We are going to have x. Here is 2 minus x. Here is 2 plus x. Alright, so let's start from x is less than the smallest number minus 2. That is the smallest number, minus 2. We also have numbers that is following x. After minus 2, we have 0. We can actually test for this. For numbers less than minus 2, there are numbers like minus 3, minus 4, minus 5 continuously. So if we pick minus 3 and test here, it will be negative, minus 3 will be negative, minus 3 will be negative. So their product, negative and negative is positive, positive, negative is negative. The next value is the smallest number, minus 2, will be less than x, will be less than 0. To test for this, if minus 2 is less than x, that means x is greater than minus 2. So the numbers greater than minus 2 are numbers like minus 1, 0, 1, 2 continuously. But it says also less than 0. So we are taking only minus 1. If you test minus 1 here to be negative, minus 1 here will be positive, minus 1 here will be positive. Negative, positive is negative, and positive is negative. The next value is to test for x. We have combined minus 2 here. So now the next thing is to test for minus 2 is less than x. Minus 2 is less than x. Or is it 0, minus 2 and 2. So you have compared the smallest number here with x and its following one. So now to start from the 0. That is the second smallest number. 0 is less than x and is less than 2. If 0 is less than x, that means x is greater than 0. So we use number like 1 here, will be positive, 1 here will be positive, 1 here will be positive. So their product is positive. So the last one, it will be x is greater than the biggest number, which is 2. If you use 2 here, it is positive. 2 here, it is positive. 2 here, it is positive. So how do you get your domain? From here, we have greater than or equal to. So it's telling you that we are picking the positive numbers. So the range we are having here are the ranges we are going to take as a domain. So if 0 is less than 1, if 0 is less than x, that means x is greater than 0, which is 1. So our range is 1, domain is 1. Here our domain is 3. Then for the range, to substitute 1 here, if we put 1 here, we are going to have 4 times 1 is 4. 1 square is 1, which is 3. So we have the square root of 3 as our first range. If you also substitute 3 here, 3 into this position, 4 times 3 is 12. 3 square is 9. 12, take away 9 is 4. So that means we are going to have the square root of 4, because this 1 over 2 as the power means square root of 4. So the square root of 3 will still repeat itself here as, because an irrational number. It's an irrational number. So this is the domain and this is the range. So I will leave this for you as an assignment. But let me give you a hint. For this function to have real numbers, the denominator here must be greater than 0. So you equate everything here to be greater than 0. Get the value for x as your domain, and substitute it to get your range. Okay, don't forget to subscribe, share, like, and comment, and send me constructive criticisms. Or you can contact me on my WhatsApp number 0814